Excuse me. All right, everybody, here are the notes for 6.1 if you aren't in class and can't do them there. Okay, so let's jump right into this. So module 6 is writing linear equations. So we have one more module here where we're going to be working with linear equations and doing a lot of the same things. So let's jump right into it. The first thing for the vocab is the slope formula. Now this is the slope formula that we have used a little bit in module 5. That is the y2 minus, y2 minus y1 over x2 minus x1. So remember, that formula is what we used in the tables sometimes, right? We used them in the tables to find what the slope was. You take two y values and subtract them, and then take their two x values and subtract them and put those on the bottom. Okay, we did that with the tables. And then slope-intercept form, again, remember, is y equals mx plus b. So that same stuff, m is still the slope, b is still the y-intercept. All of that same stuff we're going to be using here again. Okay, so let's jump right into example A. And it says, Greta makes clay mugs and bowls as gifts at the Crafty Studio. She pays a membership fee of $15 a month and an equipment fee of $3 an hour to use the potter's wheel, table, and kiln. Write an equation in slope-intercept form that Greta can use to calculate her monthly cost. Okay, and then there's a couple questions that we need to answer after that, after we write our equation. So this one, all the information that we need is right there in the problem. So she has a membership fee of $15 a month, an equipment fee of $3 an hour. Okay, so we're supposed to write an equation, and usually when we write these equations from a problem like this or from a situation is that we look for two things. Is there a starting value? And then we look for what is the rate, because the rate is always the slope. The confusing part here is it says $15 a month, that's a rate, $3 an hour, that's also a rate. So it seems like we have two rates here. But the key thing to remember is it says in the question, she needs to calculate her monthly cost, or in other words, how much does it cost for 1 month? Okay, so if we're talking about just 1 month, she pays that membership fee of $15 one time, right? If for that month, she pays it just one time. So our starting value, or our y-intercept, would be 15. Okay, her other costs come from the equipment that she uses. Now that's going to be the part that we don't know for the month, how much she's going to use it, right? So if we use x to be the number of hours and it's $3 an hour, then it should be 3x plus 15. $3 an hour to use the equipment plus the $15 that she had to pay right at the beginning of the month. Okay, that's for 1 month, right? Her monthly cost. Okay, so if we wanted to do like something else besides that, then that would be a different conversation. Okay, so the next part down here, the couple questions. How much would it cost Greta during the first month if she spent 8 hours making pottery? So to do that, all we got to do is take 8 and plug it in for x and see what that equals. Okay, that's it. Just use your equation that you made, plug in the number and see what we get. So 3 times 8 is 24. Sorry, not a lot of space here. And then 24 plus 15, that would be 39. So it cost her $39. $39 to use it for 8 hours. So it says, how much would it cost Greta during the first month if she was too busy to make any pottery? So if she didn't go there at all, she didn't use anything at all, she still would have to pay the $15, right? That's what that is asking. What's that starting value and how much would it cost? Okay, so if you pay a membership fee somewhere and then you also have to pay an additional amount every time you go there, like per hour, if you don't use it, you still got to pay for it, okay? Okay, let's go to example B here. So example B, you see we have this graph. It says a video club charges a one-time membership fee plus a rental fee for each DVD borrowed. Use the graph to write an equation in slope-intercept form to represent the amount spent Y on X DVD rentals. So this problem's getting old already because we don't have this type of stuff anymore. So all of the things that I asked here on the left are things that we've done a million times over the last few modules. So let's go back here and look. First thing we want to do is find the slope. Whenever I want to find the slope from a graph, I'm going to use rise over run. Now the weird part here is if you look at this, okay, it might seem easy right at the start. Look at where the dots are located. A lot of these dots are located like not in nice spots. So I'm going to be very careful with what I pick. So let me change colors so we can see a little better. So right here where the y-intercept is, that dot looks like a good one, and then the next one isn't until like all the way up here. So those are the two dots that I'm going to use to find the rise over run. Using anything else, I'd have to kind of guess where they would be for some of these. So my rise over run. So here I got to be very careful. My numbers are going by, looks like they're going by 2s, right? So I like to write those in. So I'm at 8 going to 18, so I'm going up 10 and over. The x values are also going over by 2, so I'm going over 8, right? Up 10 and over 8. So for the slope, up 10, yeah. So for the slope is 10 over 8. Now, that reduces to 5 over 4, right? Divide that by 2. So let's just keep going. I'll come back to that in a minute. There's something else I want to say about that. The y-intercept would be 8, right? Where it crosses the y-axis would be 8. And so the equation would be y equals 5/4 x plus 8. Okay, so the next two questions, these are the ones that might be a little more difficult. It says, what does the value of the slope represent? Okay, the value of the slope. So the slope represents, if we, in this you might need to go back and reread the question, but it says a video club charges a one-time membership fee plus a rental fee for each DVD borrowed. So the value of the slope represents the cost for each DVD. And this is the part where I kind of paused up at the top for slope. I would said 5/4, because since we're talking about money, saying 5/4 doesn't make a ton of sense. I left it that way because of the graph and everything, but if we would take a calculator and divide that out, 5 over 4 equals 1.25. Or in other words, each DVD that you rent is $1.25 in this case. Okay, and then the meaning of the y-intercept, that's the starting value. That would be the one-time membership fee. Okay, that y-intercept, that's always like the starting value. What do I got to pay at the start? Okay, all right, good. Now, the next part is a your turn problem, so go ahead and give that one a shot and see if you can get that. You can see it has a graph and then some information to go along with it. Okay, all right, so, excuse me, last one is example C. So let's read through this. This one's a little bit different. It says the rent charge for a space in an office building is a linear relationship related to the size of the space rented. Write an equation in slope-intercept form for the rent at West Main Street office rentals. So we're going to use this stuff right over here that I'm highlighting, where it says monthly rates. That's the information that we need. So it says here that the monthly rates, are 600 square feet for $750 and 900 square feet, for $1,150. So this doesn't tell us, what it is. It doesn't give us a rate. It doesn't give us a starting value. It doesn't give us anything. It just gives us those two things. But here's what we can do, okay, is we can, and what I'm going to do is I'm going to make a little table. Okay, I'm going to make a little table here, and just kind of trust me on this, the way I do this. I'm going to put 600 here, 900 here. Okay, those will be my x values, be the feet. And then I'll say that the 750 and 1150, the money, is the y. That's almost always how it is the y is the money. Okay, now, you might be wondering, why did you leave spaces? I'll get to that here in a second. So now that I put this into a table, what can we do to find the slope? We can do y2 minus y1 over x2 minus x1, y minus y over x minus x. So we can just use what we have done in the past. Okay, the only difference here is they didn't give us a table, they gave us some actual numbers in a situation. I just put them into a table so that I could get a better idea of what I was looking at. Okay, so 1150 minus 750 is 400. 900 minus 600 is 300, of course, and that would reduce to, you can just kind of knock out the zeros, this would be 4/3. I'm going to leave that as 4/3 for now. Okay, so the second part here, so I know my equation is going to be y equals 4/3 x, and then now I got to figure out what the y-intercept is. That's why I left some spaces in my table. So I'm going to switch colors here because I'm going to use, like we did in Module 5, I'm going to use the pattern of the table and go back. Okay, so this is going by 300, right? This is going by 400. So if I go back, try to keep this pattern going, that means this would have to be 300, right? Because that works with that. 300 plus 300 is 600. If I go back $400 here, that would be, what would it be, $350. Okay, and then I can't remember, I know somebody said this once in class, but remember when I'm going back, even though I'm adding, when I go back, I can subtract. Now the nice thing here is, if I go back one more spot, that gets me to 0, right? Which is what I want. And so here, this would have to be negative 50, right? Negative 50 plus 400 is 350. So this is a little bit different of an equation when we're talking about money because it has a minus 50 on it. But according to what they have started here, 600 feet for 750, 900 square feet for 1150, this would be the equation that we would use to find how much it costs. Okay, so from here, from here what I would do, since this is my equation, okay, that is my equation. So, and you might be thinking to yourself, well, so it looks like if you have a, something that's 10 square feet, they're going to pay you money to rent it. Obviously not. Nobody's going to have an office that's that small. 10 square feet is a space that you could barely stand in. Okay, so that's why the equation might look a little weird with the minus 50 on the end, but again, there's never going to be something small enough that you would have a negative number. So the question here at the bottom is how much would it cost for 1,100 square foot office? We're just going to plug that in. Y equals 4/3 times 1,100 minus 50. And if I remember right, I think this comes out to a ugly number, but so I'm going to use my my calculator. Times 1,100 minus 50. So I got, what did I get? Oh yeah, $1,416.67 after rounding off. Okay, which, if you look at the pricing over here, look at that pricing over there. 900 square feet is $1,150. So for a 1,100 square foot office, 200 more square feet, I got a bigger number there. Okay, so the your turn problem, even though this one is an entirely different situation, talking about chores, you're going to want to do the same thing, the same type of thing that I just did in example C. Okay, make a chart or make a table, and then do what we did back in Module 5 to find your equation and answer the question. Okay, if you have any questions on those your turn problems, of course, let me know, email me, or talk to me next time you see me in class.